Hey students, welcome back from spring break. I know you guys are probably as depressed as I am, so hang in there. Teachers are human too, so um, I love all the students I teach. I have a good time with them. However, I also love my breaks, and so we had a good time around my house. I'm sure you guys did too. And so hang in there. At least when the spring break is over, that means you're a week closer to graduation and a week closer to your senior trip. And by the way, the last senior class that I took on a senior trip, I went to New York City, like you guys are doing. I believe I heard New York City. So you'll have a lot of fun. We had a lot of fun. And I do need one thing from you guys. If any of you are going on the Nationals trip, I think it's next week for competitions, speech, solos, whatever they do. I don't know a lot about that. It's not exactly my area of expertise, but if you're taking that trip, I need to know. You can call me, email me, whatever you want to do, but I need to know that, okay? I'm going to try to remind you every day, but if I don't, it is your fault for not telling me, so please let me know if you're going on that trip. There will be a quiz on Friday, so understand that. It is back to the grind. We've got to do that. You guys owe me nothing. Ashley, I got your test yesterday. I did not grade your makeup test. That is my fault. I apologize. I'll try to get that done the next couple of days and get that incomplete taken off of your third 9 weeks, okay? Okay. Guys, we're starting chapter 9. I want to tell you something right now. Um, it's work, and you're going to have to do the homework. Uh, I give you these videos to help you, these homework videos. And I don't care if you're track 1 or track 2. Work is work and homework is homework. The idea in a track 2 math class is not to make it easier. Well, that's not true. It's not to make it so you don't have to do work. It's just to make the math a little easier. But you've still got to do the homework. You've still got to study. Okay? So this first lesson we're going to look at, lesson 9.1 right here. I'm going to tell you something right now. The very first lesson in most chapters is extremely important, and this one is not different. We're going to look at a lot of definitions, a lot of names of different things. You need to pay attention. You need to get this. You need to take really good notes. If you don't, when I start talking about polyhedras, prisms, faces, edges, vertices, cylinders, pyramids, etc., you're going to be lost, okay? So please take some really good notes. Let's have a great day today. I'm not going to try to do cartwheels and entertain you. We've got to take some notes, so let's get after it. Grab your notebooks, and I'll pause a second while you're doing that. Please copy this into your notes. We're looking today at solid figures, lesson 9.1, and the date today is the 1st, okay? April Fool's Day, so be careful today if some people try to trick you. Solid figures, lesson 9.1, and today is the 1st. Now, let me start off by saying this. Let me tell you this. Everything we've done so far, don't write this down, but everything we've done, or most of the stuff we've done so far, has been like flat figures, like a rectangle, or a circle, or a triangle. And those aren't solid figures, okay? And that's what we're looking at today, is solid figures. Okay, I want you to go ahead and write down this definition, so copy this down, please. A solid is a three-dimensional figure. You need to know that. That will be on your quiz. Please copy that in your notes. I'll pause a second here while you write that down. What is a solid? It's a three-dimensional figure. Let me show you what I mean. If you don't want to write this down, you don't have to, but this would be a three-dimensional figure, something like this. That's called a cylinder. You see how that's three-dimensional? It has space inside of it. You could pour water into it, or whatever. This would be like a box that you would get in the mail, or if you bought something, okay? That's a three-dimensional figure, all right? I'm really lame at my drawings, and you'll see that as we go along. In fact, I just proved it right there, didn't I? I was going to try to draw a pyramid, but I'll do that while I'm talking. But you get the point. A three-dimensional figure is something that has an inside to it, okay? And that's kind of a pyramid, more or less, but you get the idea. So that's what a solid is a three-dimensional figure, and that's what we're going to be dealing with, not a lot, but this entire chapter. Volume, surface area, definitions, okay? So we're going to be looking this entire chapter at solid figures, three-dimensional figures. I need you to write this definition down, and then I'm going to give you a truckload of examples. So please copy this down. What is a polyhedron? It is a solid. Now we just talked about what a solid is, okay? It is a solid that is formed by polygons. Now let me tell you, let me show you what the plural form would be, and I would encourage you to write this down also. You have one polyhedron, you have two polyhedra, okay? And that is how you pronounce that for plural. So just so you know, one polyhedron, two or three or four polyhedra. That's the plural form of polyhedron. Now a polyhedron is a solid that is formed by polygons. That is so important. Now would you please focus and listen to me. Remember what a polygon is? It's a shape that's formed by segments, like that. This would not be a polygon. That's not segments, that's curved. That's a curved shape. So a polyhedron is a solid that's formed by polygons. Now, you can write down all of these examples I'm going to give you. I think it's about 4 or 6. I'm not sure how many. 4, I believe. You can copy these down, or you can just sit there and listen. That's up to you. But that right there would be an example of a polyhedron. Now, can I please explain why? Would you please listen to me? Look at this top side. I'm going to highlight it in red for you. Do you see that top side is highlighted in red? Isn't that a polygon? Sure, it's a rectangle. It's a rectangle. All of its sides are made of segments. That's a polygon. Look at the bottom, please. See that bottom face, that bottom side? Isn't that a polygon? Remember, a polygon is just a so many sided figure made by segments. Well, sure, that's a polygon. Do you see what I'm doing here? You have to check every face. Let's look at the right side. Here's the right side of this polyhedron. Isn't that a polygon? Sure it is. Okay, let's see if this left side is a polygon. Sure it is. It's a rectangle. Definitely. Definitely. Let's look at the front and front and back, okay? Here's the front. Well, that's a polygon. That's a rectangle. Look at the back. I'm going to highlight the back for you in red. That's a polygon. And so every single side, we call those faces actually, we'll learn that later. Every single side is made by a polygon. So that's all you need for a polyhedron. That's all you need, is all of the faces or all of the sides are made by polygons. That's all that you need. Now, students, let me give you another example. So watch this. Okay, now this would not be a polyhedron. I am being really particular today so we can have a great chapter where you know what a polyhedron is, a prism, a solid. So please listen, this is not a polyhedron. Look at this top side. Is that a polygon? Well, it can't be a polygon. It's circular shaped. Remember last chapter we looked at stuff like this and we said, is this a polygon? And we went like this and we drew a curved shape down and we said, is that a polygon? And you guys said, no, Mr. Earhart, it's not, because there's curved sides, okay? Look, there's no way this is a polyhedron because this top side right here is a circle. Plus the whole round side, this whole side right here is round. That is not a polyhedron, okay? Now, take a look at this. Why, this is a polyhedron. Watch. Why would it not be? Let's look at this left side. I'm going to highlight the left side for you. Does that help you see it? I hope it does. That's a triangle. Well, that's a polygon. We looked at the left side. Let's look at the... Okay, what's wrong here? Let's look at the right side. Here's the right side. That's really called a face. We'll look at the right face. Well, that's a triangle. That's a polygon. No problem there. Okay, let's look at the front. The front face. Well, the front face, that's a triangle. That's a polygon. Let's look at the back face. I'm going to highlight the back for you. There we go. There we go. Well, that's a polygon. And then look at the bottom. The bottom is a square. Okay? And so that is definitely a polyhedron. Okay? All right, let's continue on. This would not be a polyhedron right here. Hold on one second while I scroll up. Guys, that's a cone. You know, when you go to Baskin-Robbins, my favorite place to get ice cream, and here's a sugar cone. It's upside down. And maybe it'll help you see it a little better if we just turn the whole thing. That's a mess, isn't it? Forget that. But anyways, this is not a polyhedron. Is every single face a polygon? A polygon? Well, no. Look at this round side. Okay? Students, you only have a polyhedron when every single side. Now, later on, we're going to learn they're not called side. They're called faces. Okay? So I'm going to go ahead and use the right word, which is faces. You only have a polyhedron when every single face is a polygon. If one face is not a polygon, then you do not have a polyhedron, and you really, really, really need to understand that, please. Okay? So let's review. I'm trying to be so slow and help you guys today. You need to know what a solid is. A solid is any three-dimensional figure. That means it has depth, height, length, width. You could pour something into it. It has space on the inside. Now, what is one type of a solid? Well, a polyhedron is a solid that is formed by polygons. And then, of course, we looked at these four examples. Yes, this is a polyhedron. Check. Yes, this is. No, this is not. And no, this is not. Because not every side is a polygon on these two right here. Now, I want you to write down another definition. So we've looked so far at the following definitions. We've looked at what a solid is. We've looked at what a polyhedron is. And now we're going to look at what a prism is. Now look what a prism has to be. First of all, a prism has to be a polyhedron. If you don't have a polyhedron, then you don't have a prism. Let me say that again. If you don't have, of course, write this down while I'm talking. If you don't have a polyhedron, then you do not have a prism. Okay? A prism is a polyhedron with two congruent and parallel faces. So you must have two faces that are both what? Congruent and parallel. You must have two faces that are congruent and parallel. All right? So, with that in mind, I'm trying to think if I should go back real quick. Let me give you some examples of what a prism looks like, okay? If you'll be patient with me for 1 second. Let me go back to this page right here. Thanks for your patience. And I probably should have had these already taken care of. All right, there we go. Now, please watch carefully as to what I'm going to show you here. Now, both of these are a polyhedron, right? Let's go over this again. A polyhedron is a solid formed by polygons. All of the faces on this are polygons. All of the faces on this are polygons. So, I have two polyhedrons. This is a polyhedron, and this is a polyhedron. But guess what? Only one of these is a prism. You see, students, you can have a polyhedron that's a prism, and you can have a polyhedron that's not a prism. So what makes the difference between these two polyhedrons? Right here. You must have how many faces? You must have two faces that are what? Congruent and parallel. And if you have more than that, that's fine. But you have to have at least two congruent and parallel faces. So, do you see this top face right here? Sure you do. And use your imagination. If you had a box, See this bottom face right here? First of all, are not those two faces parallel? Sure they are. One's up here, one's down here. They'll never intersect each other, so they're parallel. Check mark. Number two, are they congruent? Well, sure, you know when you have a box, this top face right here is congruent to the bottom. So this is a polyhedron that is also a prism. Okay? Do you see that? One side, or excuse me, two faces are both congruent and parallel. So we have a prism. Now, let me erase all this and come over here and talk to you about this other figure. Now, this is also a polyhedron, but it's not a prism because, look, students, this left side right here, it's not parallel to the parallel to the right side. They intersect. They intersect right there. Look at the front. The front is a triangle. Do you see the front right there? Doesn't the front intersect this back side here? Sure, they hit at a point. You know what a pyramid looks like. Think of all the movies you've seen with pyramids in Egypt. They come to a point. Well, here's the bottom side right here. The only way to have a prism would be, here's the bottom side, if you had a top side up here that was also a rectangle, and then it connected down to the bottom. You don't have that. You do not have a top face that is parallel or congruent to the bottom face. You must have at least two faces that are congruent and parallel for your polyhedron to be a prism. So, can you have a polyhedron that is a prism? Yes. Can you have a polyhedron that is not a prism? Yes. Okay? And you say, well, Mr. Earhart, what about a cylinder? Okay, what about a cylinder? A cylinder is not a polyhedron, right? Look at that round face right there. A polyhedron is a solid that has polygons for its faces. Okay, so we know it's not a polyhedron. So we know it can't be a prism either because a prism has to be a polyhedron. So a cylinder would be neither one. It's not a polyhedron. It's not a prism. Okay? All right, let's continue on. And let's see what else we need to talk about here. Okay, let's start getting into now, students, naming some of these prisms, okay? So please listen carefully. Let's start naming some of these prisms. Now, first of all, this here is not a prism, so we just would call this a pyramid. Let me get in the right mode here. I apologize. We would call this a pyramid. Okay? But you know what type of pyramid this would be? This would be called a rectangular pyramid. Why? Because look at the base that it's setting on. Okay? It's setting on a rectangle. I'm going to pause for a second while you guys turn in your books, and please do so quickly, to page 473. Page 473. Please turn over there. And you're going to need to go to that page in just a second anyways for a couple problems we're going to do. But please turn over to page 473. I'm going to pause. Just let the video run. I want to show you a couple things on that page. If you hear that weird noise, I'm just drinking water here while I'm trying to teach you, so just ignore that, please. Okay, please turn over to page 473. Now, if you'll look up top, you'll see where it says a triangular pyramid. Do you see that? Top right, there's an example of a triangular pyramid. Now, that's called a triangular pyramid because look at the base. The base that the pyramid is setting on is shaped like a what? A triangle. So we know it's a pyramid because the top comes to a point like a pyramid does. But what type of pyramid is it? A triangular pyramid. Now look at the screen up here, please. This pyramid here that my pen is circling right now, this pyramid right here, do you see why we call that a rectangular pyramid? Because the base that the pyramid is setting on is a rectangle. So we call that a rectangular pyramid. Okay? Now, this over here is a prism. We've already decided that, okay? Well, this is called a rectangular prism, okay? A rectangular prism. Because again, look at its base. It's a rectangle, so we call this a rectangular prism. Rectangular. So we're naming these by what their base is. Okay? Alright. I want you to look down. Here's what I want you to do. Instead of trying to copy these figures in your notes, and believe you me, I can't. Look what I did. I cut and pasted. I know that's a little blurry, but I don't expect you to draw that. What I would like you to do is take your notes and write page 473, example 1A. Would you take a second and do that? Because then you'll know where this problem came from, and then you won't have to copy this drawing or try to draw this solid, this figure into your notes, okay? So you're already on page 473. We're going to look at example 1A, okay? All right, here we go. We're going to tell whether the solid is a polyhedron. If so, I'm just reading the directions for example 1A. If it is, identify the shape of the bases, then name the solid. All right, here we go. First of all, is this a polyhedron? Well, a polyhedron is a solid in which all of its faces are polygons. Well, this top side here is a triangle. That's a polygon, so we're good there. The bottom of this thing is a triangle, so that's good. That's good. That's going to be that's a polygon. Looks like the left side here is a rectangle. Do you see that? Looks like the right side over here is a triangle. Okay, so that's good. And then it looks like the front side right here is a rectangle. So yes, we do have a polyhedron. All of the faces are polygons, so we'd say yes, polyhedron. And then it says name the solid. Okay, well look, this would be a rectangular prism. I'm going to highlight the top for you in red. Here's the top. Does everybody see that okay? Everybody see that? And here's the bottom right here. Okay, now the top, what do we need to have a prism? Well, you have to have two faces that are parallel and congruent. So this top side and this bottom side right here are both parallel and congruent. So we know that we have a prism, and we call that a triangular prism. Well, Mr. Earhart, how do you know what side to name it by? There's rectangles. Well, I'm glad that you asked. Thank you for asking that question. You go by the sides that are what? Remember? Two faces have to be parallel and what else? Congruent. So you find the two faces that are both parallel and congruent, and then you name the prism after those shapes. So it's the triangular sides that are parallel and congruent, so we call this a triangular prism. A triangular prism. Okay, now in your notes, I would like you to write this down, please. Don't try to copy the figure. That takes too long. Just write page 473, example 1b. Okay, page 473, example 1b. They want us to state whether it's a polyhedron, and if so, give the name of it. Now, look, there's no way that's a polyhedron, so we're done. No. I mean, look at this. All of the sides have to be polygons. Well, this top side's not a polygon. That's round. The bottom side's not a polygon. It's round. So, no, we do not have a polyhedron. Okay? Now, this next problem here is an extra example out of the book. You're just going to have to, maybe you can just sit there and watch, okay? If you want to try to copy this figure, feel free to, or you can just sit here and watch. First of all, is this a polyhedron? And if it is, then tell me the name. Well, yes, it's a polyhedron. Look at all of the sides, or all the faces. All of the faces are polygons. Every single face. I'm not going to take time and highlight them all, but you can see. All of the faces are either rectangles or squares. So yes, it is a polyhedron. Now, I'm going to take my pen and I'm going to highlight the bottom face. There it is. That's what it's resting on. Now, look at this top face. Are those two faces parallel? Yes, they are. Are those two faces congruent? Yes, they are. So if they're congruent and they're parallel, then I have a prism, and we name our prism by what the base is, and of course it's a rectangle. So we have a rectangular prism. A rectangular prism. All right? Okay, let's continue on. Now, there's no way in the world I expect you to draw this next diagram or figure, but just watch and listen, okay? Students, this shouldn't freak you out. I mean, look. Yes, it's a polyhedron. Every single face is a polygon. Sure, the top looks a little weird, but it's still got all segments, nothing curved. So yes, we have a polyhedron. So I'm going to put yes, polyhedron. Just kind of watch this. Now let's name it. Well, I've got a question for you. I know it's hard to see, and I drew this kind of freehand, so it looks pretty rough, but the bottom, the base, is definitely parallel to the top face, and they're congruent. I mean, I'm making that assumption. On a test or a quiz, I'm not going to try to trick you. So the top face and the bottom face are both parallel and congruent, so we know we have a prism. Now, what type of prism do we have? Okay? Now, count the sides on the bottom. 1, 2, 3, 4, 5, 6. So my base is a hexagon, so we call this a hexagonal, kind of a fun word to say, hexagonal prism. That is a hexagonal prism because the bottom has 6 sides. It could be a heptagonal prism, okay, if it had 5 sides, but it is a prism. All right. Now, I do want you, and I'm using your books a lot today because I know you can't draw these things probably that easily. And we're almost done with the notes. We're just about finished, okay? So let's review before I go on. Let's review. We talked about solids, a 3-dimensional figure. We talked about polyhedra, that's plural. We talked about solids. We talked about polyhedra. And what is polyhedra? It's a solid that is made up of all polygons, okay? Then we talked about a prism. What is a prism? It's a polyhedra. Okay, so you have to have a polyhedra or polyhedron. So a prism is a polyhedron in which we have 2 faces that are both parallel and congruent. Okay, and now let's quickly, if you'll turn your book to page 474, would you do that for me, please? Again, in your notes, I would write this. If you want to, I mean, at least it saves you trying to draw this figure. Okay, now look, if you will look at the screen here and let me teach you, you'll see what they're saying. Are you ready? A face is any whole side. It's a plane. So there, that's what I call a face right there. Okay, you need to know what a face is. See the front of this thing? It's a trapezoid shape. This whole front right here, that's a face. That is a face. Okay. This right side here, that's a face. So any of the sides, they're not called sides, but they are faces is what they are. Now, do you see where these two faces intersect right here, this line going down? We call that an edge. Do you see it? That's an edge. This is 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 an edge. Do you see that okay? So what's a vertex? Well, a vertex is where 3 or more, no, it'd be actually where 3 edges intersect. So there's a vertex. Here's a vertex. Here's a vertex. Here's a vertex. It's where 3 edges intersect. Now, I'm not going to quiz you on any of these definitions of face, vertex, or edge. I'm trying to show you what a vertex is. Do you see what it is? You should be able to count vertices. Vertices is just plural for vertex. You should be able to count vertices, know how many there are. You should be able to recognize them. It's not that hard, okay? So if I asked you how many faces this solid had, it'd be 1, 2, 3, 4, 5, 6. 6 faces. How many edges does it have? Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I counted quickly. I believe that's 12 edges all the way around. How many vertices? Well, 8. 8 vertices. Okay? All right, so that's page 474 up top. You need to be familiar with these 3 words: face, vertex, edge. Please, please, please go home and study tonight and be ready for that. Okay, now, and I'm not being lazy, just having you turn your books, but we're going to do it a lot in this chapter because it's really hard to draw these figures, and they're right there in your book. Now, do you see how these are prisms? Do you see how the top side right here matches, is parallel and congruent to the bottom? See how this top side here is parallel and congruent to the bottom side. See how this top side here is parallel and congruent to the bottom side. Okay? So we have prisms. Now these are pyramids. You can see that. They all come to a point up top. Okay? So all these are pyramids. We call this, let's go back up. We call this a rectangular prism because the bases are rectangular. We call this a triangular prism because the base is a triangle. We call this a square prism, or a cube is fine, but a square prism because the base is a square. We call this a rectangular pyramid because the base is a rectangle. We call this a triangular pyramid because the base, look at the base. The base is a triangle. We call this a pentagonal pyramid because look at the base, has 5 sides. 1, 2, 3, 4, 5. There's the base. It has 5 sides, so we call it a pentagonal. It's not a prism, it's a pyramid. Of course, you know we call this a cylinder, we call this a cone, and we call this a sphere. All right? Students always laugh at how I say that, but it's a sphere. All right? So that's what you need to know. I want you to work diligently on your homework. Please don't forget, if you need to watch a video tonight, it's Berean Academy Geometry. Remember how last time we met, we always thought we'd just say BAG for now. BAG means Berean Academy Geometry, then 9-1, and then homework. Okay? Homework. And there we go. All right, so here's your homework. I want you to get started right away if there's time left in class. I know it looks like a lot. It's not. Even if it is, it's good for you, but it's not. It's all just tell what type of prism this is, or this polyhedron, or whatever. And so it's not that difficult. I want you to work on this. It is due tomorrow. I want it done. If you need help, please watch the video to help you, okay? Have a great day, guys. Quiz on Friday. I will not be in this week, but you'll have a quiz on Friday. All right?